charged particles will have an effect on other charged particles. For example, if they're both similar, they'll have a repelling force, like if they're both positive. But if they're dissimilar, like a positive and negative charge, they will have an attraction force. In specific terms, if you comb a hairbrush through your hair, it'll gather the electrons and the brush will become negatively charged. Water, which is a polar molecule, meaning it's both positive and negative, will realign itself when you introduce that negative charge. The negative charge of the hairbrush will be drawn to the positive charge of the water, and it will cause the water to bend. This bend can be measured. So our theory is we're going to take a brush and we're going to have it with a few strokes, say 5, and we'll gather a charge and we'll do our measurements, and then we'll go back and do it with 10 strokes. And that greater amount of charge should produce a greater change in how much the water bends.
Physics with Igor!
Bending water with electricity. First you will need a laboratory sink with running water.
Next you will need 2 different brushes of different sizes.
Next you will need a meter stick and a ruler.
Next you will need 8.
Step 1. Measure the surface area of each brush and the height. Step 2. Go over to the faucet and turn the water to a steady stream. Then tape the ruler on the sink with the stream at an initial point and record the initial point. Step 3. Pick a person in the group to have their hair brushed. This is to create their static electricity. Make sure they brush their hair before the experiment.
Step 4. Brush the hair 5 times. Now place it 1 centimeter away from the running water, but do not touch the stream. Watch closely as the water bends towards the brush. Step 6. Measure the displacement that the stream bends using the ruler at the bottom of the sink. Step 7. Move the brush further from the stream by increments of 1 centimeter. And now measure the displacement of the stream with each movement of the brush. Repeat step 4 through 7, but this time brushing the hair 10 times. After that, step 9, repeat steps 4 through 8 with the last brush. Bending water with electricity.
We hope you enjoy conducting the lab.
Great job, kiddos.
Thank you, Igor. You taught us so much.
Now that we are done with this experiment, I'm just going to go through and see what's going on. We have these molecules that are coming out, just water molecules. They're going to be flowing down, and since we don't have a brush, it's going to fall down on this first X point. So I have it marked as X1, and in this example, it's 30. But when we add a brush to the scheme, they all align with the negatives coming from the brush, with the positives being attracted. So let's come back over here. What's going on is these hydrogen is trying to get a hold of this brush, and the oxygen is being repelled. So that's why we have this bend. And it's uniform throughout the entire stream. How can we measure this? That's what I'm here for. So we're going to have this full data sheet. We're going to start off with brush number 1, right? And with our first distance from the stream, we're going to have it marked as BX. So BX1 is going to be our first distance from the stream, then BX2, then BX3, and then you're going to repeat for 10 strokes and so on and so forth. And then, this is where it gets interesting, you get to watch the stream bend, and it lands on the next X point on this ruler or a meter stick, whatever you're using. So, and what we're going to measure is this change in X, which is going to be our final X minus our initial X. And in this example, it's going to be somewhere from 30 to 10, so it's around a change of 20, whether it's centimeters or inches, whatever you're going to be using.
Okay, so after we've done the experiment and we've recorded the data, it's time to make conclusions. One thing we notice when we do our experiment is that when the brush is higher on the water, closer to the source, the water moves farther. When we were doing the experiment, we found when we bring the brush lower, it'll only be maybe 2 centimeters different or something. But so we concluded that the higher the electric force is to the source, then it causes a greater change in X. And also, here's another great thing we notice. As time elapses, it causes a loss in charge. Now we have electrons loaded up on this brush. After we brush the hair, we have electrons all over it. And as time elapses, the electrons get lost to the atmosphere. And so, you know, we might hold the brush here for 5 seconds, but this stream will start going back because the loss of electrons. Also, a few other things we've noticed. We had 2 sizes of brushes here. We had brush 1, brush 2. They're 2 different sizes. When the volume of the brush increased, then the change in X increased because we held more charge on the brush, so therefore X moved more. Also, we noticed that when we increased the number of strokes on the brush, we increased the amount of static electricity, so the change in X was greater. Also, when we also noticed that the change in X, it went down whenever we moved the brush farther from the stream of water. It's funny!
La, 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 la.
I guess we're gonna...
Are we going to point at it?
Yeah.
Is that yum or what?
Oh, wait, is that young physics or
I
what?
could just include this whole video right now.
Yeah.
No!
But we don't need
Yeah. Hey, Mr. Layton, we enjoy doing this.
Okay,
Is that
come on.
Ready? In
Alright.
3, 2, 1. Is that yum or what?
Oh, yes.
guys.
Oh,
Good
yes.
Do we need to erase this?
job.
Oh, no, I gotta take pictures.
Physics 2, yeah, buddy.